In this example, we're told to take this big fraction, which I've shown as having some polynomial in this black font right here, and a number of factors on the bottom, and break it up into component parts. This is called partial fraction decomposition. And what I'm trying to do with this color coding is give you an idea of the pattern that we're doing here. If you look at the x squared in blue, look at the factors that produces. It produces a factor of x, and then a factor of x repeated, so x squared. Now, if that had been x cubed, I would also need a fraction that says x cubed on the bottom, and so on. If you see a factor that's just a single version of itself, like x minus 1 in green, that's going to be only a single fraction of x minus 1 on the bottom. And this pattern will continue even when you have nonlinear factors, such as quadratics. In the purple, I have x squared plus x plus 3. That's an irreducible quadratic. And it's squared, so I need one fraction with this as a single quadratic factor on the bottom, and another fraction with this as a quadratic factor on the bottom. Now, the other pattern that you'll see is if you look at the top of these partial fractions that I've made, take a look at what we have on the bottom. In blue and green right here, we have linear factors, and on the top of each of those fractions are constants. Okay, so those are constant numbers, like 1, -3. They could even be fractions, whatever. And now over here, if you look at the quadratic factors, those don't have constants on the top. They have linear factors on the top. So whatever the factor is on the bottom, you need to go 1 degree less than that on the top. If it's linear on the bottom, you go constant on top. If it's quadratic on bottom, you go linear on top. So I'm going to use that idea to construct, first, to construct a setup for this fraction right here that we're going to solve in this problem. And then we'll go about actually finding the solution. So if you look at what we have on the bottom, I have already written this in factored form. We've got a linear factor and a quadratic factor. So let's turn this into some fractions that we can use. The linear fraction is going to be some constants on top, a, divided by y plus 3. And then the next fraction is going to be, the denominator will be a little bigger on this one, because it's that quadratic. I can't factor y squared plus y plus 2. Or if I did, I would get imaginary factors. So we call this irreducible. Now, because that's quadratic, on the top I need to say bx plus c. I need a linear factor on top. And now we go about balancing this equation. So remember, this thing is equal to what I have on the right side right here. And the way we're going to do this is through multiplication. We've done this a number of times in class and through other videos. So I'm going to go through this step a little faster. And if you need to prove to yourself why the following that I'm writing is true, go ahead. Pause the video in just a moment and compare the line I had just previous to this one and this one right here to see what's happening. Basically, this is multiplication. I'm multiplying both sides of this equation by the factors y plus 3 and y squared plus y plus 2. And I get this. So now we go through the process of trying to figure out what a, b, and c are. Okay, once I find these things right here, a, b, and, whoops, that's not c, a, b, and c, I will have the solution to my partial fraction decomposition. I'll know how to write it in this form right here. And that's all we're trying to do. We're not trying to figure out what y equals. Although, there are some test cases of y that we can use, which are helpful. This is called the Heaviside Method. When we say, well, what if our variable y were equal to something? Okay, I think -3 would be a very convenient value of y. So let's say, what if y equals -3? Well, let's see what happens. Okay, so we're going to get this. -2 times -3 squared minus 2 times -3 minus 20. That's the left side of the equation. Now on the right side, you'll see why I'm doing this in a moment. This actually has a good reason. -3 squared plus -3 plus 2 all times a, and now plus, watch this, it's b times -3 plus c times -3 plus 3. Now, all the way on the right side, this over here, this is the whole reason I chose y equals -3. This becomes 0, which means it crosses out the whole thing. And now all I have left is some numbers. So let's figure out what we have remaining? Well, remember, it's very important that you go through this one step at a time. These are honestly easy maths. It's just multiplying and adding. But there's so much of it going on that if you make the smallest mistake, it could be a real pain in the neck as you try to figure out what went wrong. 9 minus 3 plus 2. So forgive me if I'm writing this all out in detail. But we get negative 18 plus 6 minus 20 equals a times 6, 8, I think. Okay, so let's keep on going here. This is negative 38. I think this is negative 32 on the left and a times 8 on the right. Well, that means a equals negative 4. Now that right there is what we get for the Heaviside method. We solve for one of these a, b, or c values. And that's really useful because without that, you would have had to use matrices or some of the more advanced systems of equation solutions that we've talked about. So let's take this a equals negative 4 and go back to our original equation. We're going to plug this guy in right here. Okay, that's what a is equal to. But if you look at these other values that we have, there might be other ways to pick nice values of x that make things go away. So maybe think about what value of x you want to try next. But I'm going to plug in a equals negative 4. We're going to work on this for a moment. Negative 2y squared minus 2y minus 20 equals negative 4 times y squared plus y plus 2 plus bx plus c times y plus 3. Okay, so how did this x get in here? Oh my gosh. You guys have probably been chuckling at me for a little while now. Okay, that's a y right there. Just notice this now. Okay, so that's a y value. Anyway, moving forward, let's FOIL this out. I think there's a pretty good way to figure out either b or c coming up, but I want to simplify this more if we can. This becomes negative 2y squared minus 2y minus 20 equals negative 4y squared minus 4y minus 8 plus, and I'm going to keep this one factored over here because I have plans for that. Okay, and now let's just bring things over to the other side. We're going to have 2y squared when I add 4y squared to both sides, right? And then next I'm going to add 4y to both sides, right? That was this guy. And then I'll add 8 to both sides. Okay, so this is progress. Important thing about partial fraction decomposition is to be patient with it and just give it time for things to sort themselves out. The next thing I'm going to try, we're going to dip back into Heaviside for a second here. Let's try this. I'm going to say, what if y equals 0? What happens then? Well, let's try it out. We'll see where we go. This becomes 2 times 0 squared plus 2 times 0 minus 12 equals b times 0. And that's the real reason I'm choosing y equals 0. 0 plus 3. Okay, that's what happens if y equals 0. Well, let's see what we get from this. On the left side, it crosses out very quickly. That's negative 12. On the right side, I get 3c. Okay, so c equals negative 4. Well, that's fantastic. Now I have a and c. Finding b should be pretty quick. So let's go ahead and plug c back into that original equation we had. I'm going to pick this guy right here before I did the Heaviside stuff. We're going to get 2y squared plus 2y minus 12 equals by minus 4 now times y plus 3. And let's go ahead and FOIL this out, or do the multiplicative distribution. This is going to be by squared, and let's see, plus 3by minus 4y minus 12. Okay, and now what you might notice, we don't need Heaviside for this last one. You might notice something that I could have honestly done in the last step. If you look at the y squared terms, I have y squareds on each side. And it has to be the same number of y squareds on each side, which means, using that logic, b equals 2, right? Because there's 2 y squareds on the left and 2 y squareds on the right. So now we have A, B, and C, and we're going to write our solution. Okay, this is everything all put together. You know what? It'll be easiest if I come back up here and just copy this guy. Let's copy this so you can see what I mean right here. Okay, so my original equation was that big thing, and it said, what is this all equal to? Well, we found through this technique that A equals -4. Okay, C was also -4, and B was 2. So this becomes 2y and then -4. Okay, and this is called the partial fraction decomposition of our original, right? It's written as simply as we can make it. I can't reduce this denominator anymore, so we just have to leave that as an irreducible quadratic. And other than the irreducible quadratic, everything is in terms of linear factors right there. Okay, a little simpler than what we started with, not a whole lot simpler, but if you were in some kind of calculus problem, you might find this handy.